In this video, we're going to look at Activity 2 in Section 2.1. In Activity 1, we took a look at bar graphs and pie charts and worked with them and percentages and analyzing them and reading data. In this activity, we're going to look at which one is better for different situations. So in this activity over here, we have a pie chart. And we're just going to answer some questions about that pie chart. This pie chart's completely unlabeled, right? But we know some things about what a pie chart means as far as the type of data it represents. So go ahead and pause the video and answer these three parts right here from question 1. Well, the first two questions are pretty straightforward. Which slice is the biggest? Looks like the orange. Would you call that orange, red, burnt orange? I don't know. It looks like burnt orange to me. Whatever you called it is fine as long as you were looking at this slice right here. That looks to be the biggest one. Which slice is the smallest? I would say this green one right here. My apologies to anybody out there who's colorblind. We could label these. Maybe we should do that. Let's say this is slice 1. Let me use black. This is slice 1, slice 2, slice 3, slice 4, slice 5. So the largest slice is slice 1 and the smallest slice is slice 4. If the whole pie represents 100%, about what percent is represented by each piece? Now I'm not going to go through these. This is kind of on you, but because it's estimating. But I will say just some guidelines. In looking at this pie chart over here, remember if you cut it exactly into 4 equal pieces, say I used this line right here, and then I put in another line, say I was visualizing another line here that's perpendicular to this line, okay? Maybe I'll put another line in here. So by doing this, I can see what 25% represents. So whatever percents you put for 1 and 2, you have some leeway there, but they need to be bigger than 25% and less than 50%, right? Somewhere around 30, 35 would be good guesses for 1 and 2. Similarly, we can see slice 5 here is less than 25%, right? And 3 and 4, those are definitely less than 25%. Possibly even less than 4 might be less than 10%. The other thing that you need to look at for your guesses here is they should all add up to 100%. So I want you to write your guesses down, and you're going to have those. I'll look at them when you turn them in. But what I'll be looking for are those things we talked about as far as estimating, and they should add up to 100%, whatever you're guessing. All right, let's go ahead and do the same kind of a thing with a bar graph. Let's look at the bar graph to the right. Again, it's not labeled. We don't know what the scale is on the vertical axis. We don't know what's being represented on the horizontal axis, but we do see how these kind of compare to each other. So answer questions A, B, and C. Pause the video and do that now. All right, which bar is the biggest? Well, it looks like A is definitely the biggest bar. Which bar is the smallest? That looks like D. If all the bars together represent 100%, about what percent is represented by each bar? Wow. Well, this is a little tough, right? You may be guessing and checking and trying to figure stuff out. But because we don't have a good sense of what the whole amount is, it's hard to get the percents. In the pie chart, we have a picture of what the whole is. The whole is the entire circle. And so I can divide the circle up into pieces and get a really good idea of what 25% of the whole is. Again, focusing on this idea about what is the whole. Down here, I don't have a very good idea about what the whole is. So whatever you guessed, all your guesses again should add up to 100%. And whatever you guessed, I'll take a look at and make some comments on your homework. But what we're trying to illustrate here is that you might have noticed that it was difficult to answer some of the questions about the graphs in the previous two problems. That might be because pie charts are good for making part to whole comparisons and bar graphs are good for making part to part comparisons. So when we talk about part to whole comparisons, that's what we need in order to determine a percent. The part to whole comparison gives us the percent. So that's why it was easier to figure out the percents in the pie chart, where it was difficult to figure out the percents in the bar graph, because the bar graph is really good for making part to part comparisons. How does part A compare to part B? How does part A compare to part D? I can see that, part D is, less than 1/3. If I took D, if each of these bars represents some amount, D doesn't even reach the first bar, and A is above the third bar. So A is, much bigger than, or I won't say much bigger, but definitely bigger than 3 times D. So that's part to part. It's comparing part A with part D, whereas pie charts are comparing more the part to the whole. In other words, how does this 3 slice compare with the entire circle? As opposed to if I asked how many times bigger is this 3 slice than this 2 slice, that's a little harder to see. That would be easier to see on a on a bar graph. So with that in mind, that means that finding a percentage out of the total is usually easier with a pie chart, and comparing the size of two groups is often easier in a bar graph. So the data in problem 1 and 2 are exactly the same. Now that might be difficult to see. In other words, remember in activity 1 how we made a bar chart out of a pie chart? Well, if we took this pie chart and made a bar graph out of it, we would get this bar graph right here. Now that you've been told that those two represent the same data, I want you to match the bars in the bar graph to their respective slices in the pie chart. So you can do that by either coming up to this pie chart here and writing which one of these slices represents the bars A, B, C, D, and E down here. Or if you want to number the slices like I did here, 1, 2, 3, 4, 5, or whatever way you want to number them, you could come to your bar chart and tell me what number slice each of these bars represents. So you go ahead and do that. I'm not going to do that in this video, but you go ahead and do that. All right, so the last thing we're going to look at here is number 4. Decide whether it would be easier to illustrate each situation with a pie chart or a bar graph. So you're going to write pie chart, or bar graph for each of these 4. Pause the video and go ahead and do that. All right, let's take a look. You want to order the categories of your personal budget: rent, food, clothing, transportation, from largest to smallest. So here we're comparing part to part, the part of our budget to some other part of our budget. All right, so if we're doing part to part, bar graphs are the way to go. So I would choose a bar graph for this one. All right, let's look at B. You want to illustrate the categories of your personal budget by percentage of the total budget or the whole budget. So we want to make a part to whole comparison. So a pie chart would be good for this. C, the weight of tests in your overall course grade. So the overall course grade, that's the whole. So let's do a pie chart for this one. So what that might look like is your pie chart would represent your overall test grade, or excuse me, your overall course grade. And then there would be some slice that would represent tests, and maybe the other slices would be like homework or projects or something like that. So in this way I could see the weight of the tests in the overall course grade, how much of the overall course grade is affected by the test scores. Part D, your performance on tests compared to your performance on homework. So if I was comparing a part of my grade to another part of my grade, a bar chart might be nice for this. So we could do a bar chart for we could do test grades, test weight and homework weight, like what percentage of your grade is affected by these things, tests, homework, projects, whatever, as opposed to a pie chart would tell us how those tests compare to the overall course grade, comparing those two things.